This is a talk about Effortless Config 101. So we're going to try to keep things high level, but then occasionally we're going to deep dive and show some code and some other things. My name's David Eccles. You can find me in all the places as EchoHack. And there's really a couple of reasons that I wanted to give this talk. One that I've heard a lot in the community is that people don't have a very clear direction around what the best practices for running and building and managing their cookbooks in 2019 is. And we've been thinking about this at Chef for a while, working on it with some of our largest customers, experimenting for several years with a whole bunch of failed experiments that I'm sure if you find me, we can talk about some of those. But ultimately, this is what we've landed on and what's been working and what I think will continue to work. The other thing is that I really want to hear your feedback about this approach to running Chef Infra and get all of your ideas so that we can improve it and make it better and go on forward into the future. So I just wanted to say a quick thank you to Jamie Windsor. Jamie Windsor was the lead engineer on Habitat for several years. He's a big inspiration to me and a big inspiration for this methodology. And I kind of view it as sort of the successor to the work that he did on the Burke Shelf Way and all of that. So he used to work at Chef. He's now moved on and made his own game company. So a quick plug for his game company, One More Game. I think they're very close to releasing their first prototype of their first game. So check them out if you like games. So really what I want to show you today is a better pattern to build and run Chef Infra. That's ultimately why we're here. And the most important thing that I knew going into this was that we had to build this together. This wasn't something that one person coding on their laptop in their basement was going to figure out in their home lab or anything like that. So we built this together with, in fact, so many people that as I started looking through all the Git commit history and the histories of the issues, and I was actually overwhelmed. I didn't realize that so many people had actually contributed to this. So I just kind of gave up and took a screenshot of the Slack, the internal Slack channel that we have here at Chef, which has 115 people. And I didn't have time to go get marketing approval for all the logos and people that we worked with, but there's an enormous number of people that came together to make this thing possible. The other thing that I want to assure you of is that I'm not coming to get rid of your old patterns and burn them to the ground. Instead, I want to show you a new pattern and introduce you to new friends. And as you might be waving goodbye to some of your old friends, you might make some more new friends on the way. So this is just a quick peek before we start deep diving into things on what the tech stack looks like. So at the top, managing everything is Chef Habitat. This is the management framework. It's the piece that's going to supervise the running Chef client. It's going to be the deployment framework that you use. It's going to be the build framework that you use. It's really the top level management framework. And all of these other pieces serve to really strengthen the deployment methodology. So and what's great about these is that they're actually all pretty old at this point, which is pretty cool. It's just a very novel way of putting together things that really hadn't been done before this actually was implemented. So we have a Policyfiles, which is really great because it gets rid of things like the role versioning problem. We're running Chef Client in local mode, and there's a lot of talk about that. your existing cookbooks that will run on this. And if you want to run your existing data bags, you can as well. That's optional. So before we deep dive into some of that stuff, I kind of want to give a little mini software pipeline talk, a little coach pep talk. We're going to have some fun in this session. This is a fun session. So mini software pipeline talk, because it matters a lot. So first of all, I promise this is a 101 session. So if you all know what a node is already, like, I don't know. So okay, what a node is. A node is what we typically call a compute resource, or the resource where everything is going to land, your operating system, your application, your middleware, your packages, your system libraries. And Corey kind of showed this layer cake diagram a little bit earlier. And so when we start talking about software pipelines, we have all these different views of them. So as a developer, you are working on your application. You might have this kind of view of the world, where you're committing to source control, and a lot of your effort and your time is spent at that stage of the project, where you're reviewing code, you're debugging things, you're testing things, primarily on your dev workstation, committing it to source and getting it built. At some point, it lands into an artifact repository, artifact storage, whatever system you plan to use. And then at some point, it gets deployed. And by and large, this deployment and node management, it's kind of magical to you. Someone probably does this for you, or you collaborate with that person. At least in the old world kind of way of doing things, right? You kind of throw it over the wall, and you're like, hey, here's my artifact. It's like, good luck. So when we start looking at it from the operator's perspective, things change a lot. Now we're responsible for running and maintaining not just one application, but we're running multiple teams' application. We're coordinating with multiple development teams across the organization, and we're helping them fix their builds. We're getting their artifacts into the artifact storage in the correct way. And then we have to figure out all this deployment tech, which is a pain in the butt. And we have to figure out how this node operates and all the things that are in it. So we have some deployments that are sticking the application on top of all the things we have on the node. We have some undocumented things about tuning the JVM and all sorts of other things that we don't want to talk about, but we know how to do that. We have some automation for deploying packages, whether you're using Chef or something else. And we need to patch these system libraries. So we have a lot of things in our responsibility sphere, so to speak. But as a business owner, if I go to the operations person and say, hey, how much money have you made for me today? They'll tell you about how much money they've cost you. And so a very naive business person would look at the equation like this. They would say, oh, OK, well, everything in source control and that artifact store, that's intellectual property. That's going to make me money at some point. And then that application, that's the thing that's going to make me a lot of money. And all this other stuff I don't care about. Like, this is an expense. So you're a cost center. So good luck. Thanks. And kind of my response to that is, what? What? That's not right. We're over here innovating things about how to deploy things faster, about how to get code to our customers faster. That's a feature in and of itself. In fact, that might be the most important feature, getting things to our customers faster. Like, we're just running around without that. We're just running around with nowhere to go, right? And if the business is oriented that way, and they're putting pressure, the business leadership is putting pressure on IT that way, a lot of times this is how we feel. We're like, oh, fuck, oh, fuck, oh, fuck, oh, fuck. And they're like, I'm doing it. And then we crash and burn, and people wonder why. So the answer to this is we have to break out of these old school model ways of thinking about our business, about thinking about how we run operations, about thinking about how we develop code. And a lot of people call this DevOps, but I wanted to kind of avoid the the jingoism, and really get to the heart of it. And the heart of it is that early and close collaboration will lead us to better products and healthier and more equitable businesses. They're more fair. So the person that's at the end of the product's life cycle doesn't get all this stuff shoveled on top of them. They don't have to deal with all the problems. They're able to collaborate the moment that the product has been conceived from that very beginning. They're, in some cases, in the dev team. In some cases, they're called a developer with an operations specialty. Depends on your org chart. So the primary place that we collaborate is also the code and the application, including its entire life cycle. So everything that allows that application to be successful, that allows it to live on compute, storage, network, all of those things, we want to be as close to the code, or we want to write code to be able to do all of those things. Okay, so at least in my view, this is kind of like the combination of all of those previous views that's a lot more healthy. We end up with only $1 for the application because now we've baked our expenses into the development life cycle of the application all the way across, right? So our operators are collaborating all the way back during the development process about how this thing is going to run in production. It's not that production is way off to the right, or that you do it later, or that you start figuring out how you're going to deploy to production 10 days before it has to go to your first early adopter customer. That's never happened to anybody in the room. We do that on day 0. We deploy the failing bit of what we might call the application at that point to our production environment, and we develop it alongside the developers. And we can really do that with some of the tech that we have here at Chef, particularly with Habitat, Chef, and Inspec. And then what's great about that is that we enter a world where the view of the application is the same no matter where it travels. So we want to be able, as a business, to be able to understand how the application's working the same everywhere. So I promised you a better pattern to build and run Chef Infra and gave you a talk about mini software pipeline, but it has a purpose. But I need to kind of rewind 5 years and talk about the environment cookbook pattern. If you don't already know, the environment cookbook pattern, this is in 2014, if you caught me at ChefConf, I think that was my second ChefConf. This is what I would have told you to do. So basically, we have 2 pipelines here. We have one for the application that we care about, and we have one for our chef cookbooks. Now, the application team and the operations team, in this case, hopefully they're collaborating. But in practice, I think a lot of times with the environment cookbook pattern, they weren't collaborating, or it was getting thrown over the wall somewhere in the middle of the process instead of all the way to the left of the process. So what we ended up with is 2 teams working sort of together in source control, building their thing, getting it out to artifact storage, and then deploying it. And what's particularly interesting is the way that the environment cookbook pattern has you deploy this. So you build your artifacts, you test them with Test Kitchen, whatever you're going to do, and then you use Burkshelf to upload all of your cookbook dependencies and everything else that you need to a Chef Infra server. When you do that, the next thing that you're going to do is create an environment lock. So there's a little JSON blob on the Chef server. It's called an environment file, and it lets you lock all of the versions of all of the cookbooks that you want to that environment file. And the whole purpose of that is so that when the Chef Infra client reaches out from the node and does a converge, that it's able to grab all the correct versions of all the cookbooks, and you won't run into any surprises like, hey, what if somebody uploaded another cookbook after you uploaded your cookbook and then it broke everything. So this way you always have a really solid way of knowing what's going to run on your infrastructure, and then when you need to do a new deploy, you need to move the pinnings of the environment lock. So this has a few problems to it. So in this diagram, what happens when the dep solver fails here? So let's say the dep solver reaches out to the chef server and then can't find the version of the chef cookbook that it says it's supposed to pick up. Well, I don't know. Something bad will happen, right? What happens when the Chef Infra client itself is incompatible with the versions of the cookbooks that you've built? Maybe your Chef Infra client is way out of date, and you're using newer, better cookbook practices that don't exist yet. So the Chef Infra client just blows up on you. Maybe you have a big operating system upgrade that you need to do, or you need to radically switch changes of your chef client distribution. That might change your cookbook requirements dramatically and how you pen them. What if your chef server is down for maintenance, particularly if you have a very large organization and you have tens of thousands of nodes, and one of the 12 organizations that uses that chef server needed to take it down for maintenance so that they could deploy their thing, but now all your nodes are down? And what if databags, attributes, and other stateful data that's on the Chef Infra server, what if that gets modified in place? Like we give someone a knife and they just so happen to change something on the Chef server without checking it into source control, and we don't really have a pipeline set up. What happens then? Well, I'll tell you what happens is that our nodes go down and that things blow up. Hopefully they fail in a graceful way, and the chef client just starts sending failure reports up. I'm getting pinged about something. Okay. All right. Oh, over here. Okay. I can do that. So hopefully things fail gracefully. But if they don't, then our node is down. We might have a customer outage, which is super bad. We don't want that. So if there's a way that we can avoid those scenarios completely, then that would be pretty great. So enter the effortless config pattern. So the idea behind the effortless config pattern, so this is the same diagram as before, just minus the second pipeline. So what we do is we have source control. We build it. We put it up into artifact storage. And then we do a deploy. And then Chef Infra lives on the node just as another app. It's just an app, just like anything else. It's not special, like in the environment cookbook pattern. So let's talk about a few use cases. So if we have really complex cookbook development practices, we have a very complex pipeline that's expensive to go through, this might be something you're really interested in. If you're experiencing a lot of runtime failures from missing version pins or missing cookbook versions or other things like that, this might be a great pattern for you. If you're looking to prepare for modernization efforts, where you want to move something from a really old operating system to a new operating system, or you want to move away from VMs entirely over to containers, this might be a great bridge for you to get there. Or if you have really challenging environments, you have standards to meet, you have an air-gapped environment where you literally have to put everything on a USB stick and walk it into the data center. If you have those kinds of challenging environments, this can really simplify your deployments. So let's go through how it all works real quick. So first, we're going to use your existing cookbooks. So you don't have to rewrite anything. There's nothing to rewrite here. We're going to write a habitat plan and a policy file. If you're not already using policy files, I'm just assuming that you're using something like roles or environments or something like that. If you're already using policy files, then your life is even easier because all you have to do is write the plan. We're going to build it in Habitat Studio. We're going to upload it to our artifact storage. We're going to install the Habitat supervisor on the node. And then we're going to load the package on the node. And that's it. That's 6 steps to get everything done, which is pretty awesome. I wish I had this like 10 years ago. So building the package, this is the entire plan.sh. And it should look very similar for your application, if not a little smaller. Like if you're not using data bags, you can delete this whole line with data bags. If you want to use the latest version of the Chef client always, you can delete that line with the Chef client. If you want to use the latest version of the Chef DK to build it, you can delete that line. And you know, this thing gets a little easier. And a lot of this is just metadata, so there's no code in here. The other thing, of course, is this is just Habitat. So if you need to do something special, like you have a custom-built version of the Chef DK, and you need to layer your gems on top so that you can build your special cookbook or whatever, that's something that you can do in here, and you can pin to whatever version of your custom thing that you have. So the main thing I want to point out here that this lets you do, or actually there's a couple things, but the main thing is this last line where it says pkg_scaffolding. So scaffolding is a Habitat concept, but essentially what we're using it here is as a encoding of all the best practices for the Chef client runtime. And so just by having this one line here, you can subscribe to a version of best practices of running Chef client. And if you don't like the newer best practices that are coming out, then you can pin to an old version. Or you can make your own, because it's all open source. So if you have your own internal company best practices for how you run Chef client, then you can build your own. Of course, you can always pin to the version of the Chef client here, too. So if you're very careful about your upgrades and you say, no, we use 14.12.9 everywhere, or you know, we want to use the community distribution of Chef client, you can do that. So you have a lot of flexibility here about how you want to build your package. And it's all very simple. So here's the policy file side of things. So the policy file does a few things. So first you have to give it a name. And what this does is allows you to specify all of the sources of your cookbooks. So whether those are coming from the supermarket, your internal private supermarket, a Chef server, Artifactory, a GitHub repo, wherever those are coming from, you can download those cookbooks and resolve those for your build. You can declare all the cookbooks that you want to pull down. And you can define the run list that you want to run, excuse me, that you want to run Chef with. I had a little bit too much bubbly here. And of course, it's not pictured here, but you can override any attributes that you need to as well. So what's really cool about this is you have one document now that has all that stateful data that lives in like 5 or 6 places on Chef server that you might have complex pipelines to update or different kinds of source control to update. You have one document where all that stuff can live. So I kind of want to deep dive into the build. We did this on stage this morning in the keynote, but it scrolled pretty fast. So let's talk about what's actually happening in the build. So when I type build, I can either, I don't have to type actually the second part. That's just whatever directory it's in. But here, for the sake of the demo, I type build effortless. The first thing it's going to do is resolve all of the runtime dependencies and build time dependencies that Chef needs. So in this case, we need get for build. We need Chef DK for the build. And we're going to need Chef client, the CA certs, and the scaffolding to actually run this thing. There's actually not more than that, really. The second part of this build is that we're going to compile the policy. And the whole point of this is that we want to take that policy file and turn it into a policyfile.lock.json file. And that lock file, which I'll show you in a second here, is going to have a lot of detailed information about all the cookbooks so that the node at runtime will have a guarantee about everything exactly it runs against. And there's no surprises. It'll cache all the cookbooks, pull them all down, that sort of thing. So if you're running this, what's nice is if you're running this in a CI server and you're not blowing that away every time or whatever, you can cache everything and it'll be really, really fast. So here's that lock JSON. The main bit here that will tell you if this thing has changed is the revision ID. This is always at the very top of your lock.json file. This was a really nice innovation after the environment cookbook pattern, so that instead of relying on some combinatoric amalgamation of different versions of the cookbooks and hoping they all kind of landed on the node successfully, which 99.9% of the time they do, but sometimes there's surprises. This just generates a shell sum, and you're good to go. And then not only that, but it'll actually generate individual cookbook locks for every single cookbook. So there's absolutely no surprises whatsoever. It'll even tell you where it comes from, because maybe you have two versions of the same cookbook, and one's in Artifactory and one's in the Chef repo, and you don't know which is which, and so the source can matter sometimes too. So the last part of the build is the actual packaging bit. And this is where you export the policy. And the policy, doing that, allows Chef 0 to run all of those vendored cookbooks and everything that was downloaded. And you can see here it says, to converge the system with the exported policy, run cd this chef client z. So it's really that simple once it's compiled. And then finally, it's going to create a tar xz file. So it really is a tarball. It's not magic. And it's going to sign that with your private key. And what's nice about that is that then you get this .heart file or .habitat artifact, and that lets you run that with the habitat supervisor at runtime. So we end up with this habitat artifact. It's a package. It has the chef client. It has our desired chef client version. It has all of our vendored cookbooks. It has run list, attributes, data bags, basically everything that we need to run at runtime and be successful. So we start thinking of the world a little bit different now. Now the package is kind of the center of the universe, and we're able to take this and go and deploy this anywhere, into our air-gapped data center, onto your dev box, onto your QA environment, stage environment, alpha, on the edge, on some Raspberry Pi, or wherever you're going to deploy it. It doesn't really matter because everything's all self-contained. So with Effortless, the way we like to think about this is now we have this package. So now we need to upload it to our artifact storage. So artifact storage in the Habitat world is Habitat Builder. There's a lot of other artifact storages out there, like Artifactory or just a S3 bucket or whatever. But the nice thing about Habitat Builder is that, well, I'll get to that in a second. So this is how you upload it. I just literally got the help text off of habpkg upload. You can grab this as well if you want to read all of this later. But this just lets you upload the heart file to Builder, whether that's your internal builder or the public builder. And so now we have this package up on our artifact server, and now we need to get it deployed onto the node. And so in the Habitat Builder world, there's actually two things going on. So the first thing is that we want to promote this to a channel. So Habitat, if you're unaware, has this concept called channels, which your nodes can subscribe to. So the node is actually looking at Habitat Builder at the package. It's subscribed to that package. And it is also subscribed to a channel. And it always looks for the latest version of whatever it's subscribed to and whatever channel it's subscribed to. So in this case, it's subscribed to the stage channel. And it's always going to pick up whatever the latest version of that stage artifact is. So this is kind of a push-pull kind of scenario. So you decide when the promotion happens, which is your push. So you say, hey, I'm ready to deploy. And you can do this in your orchestration tool or your provisioning tool or your shell script or however you want to deploy your application. This is something that I think most people would do in some sort of CI system or scheduler or something else. You can also do this by hand if you really want to. But then the node is responsible for itself. you don't have to go SSH into the node to put the thing on the box and then install it by hand. It knows how to run itself. And that's the idea behind, like one of the core ideas behind Habitat, is that it's able to be responsible for itself. So here's one of my favorite provisioners, Terraform. This is some Terraform code. This is just a snippet. We actually do have a Habitat provisioner within Terraform that makes this code a little simpler, but I just did it in shell script, so I hope a lot of people here know Bash. If you don't, then I'm sorry. I can explain this to you later in the hallway. But this is just Bash, so I'm adding the Hab user, I'm adding the Hab group, I'm chmodding a shell script that's going to pull down the supervisor, I'm creating a systemd service, I'm reloading it, starting it, and enabling it. And then this last line here is really the rub, is now that I have the Habitat supervisor installed on the system, all I have to do is run one command to load it, to subscribe to the channel that I want, the update strategy that I want. In this case, I'm binding to a database, and it'll load everything up. So let's do a bit of comparison hockey. Some of this might be a little glib, but we'll see. So some comparison hockey. So in the environment, this is upgrading the Chef Infra client. So in the environment cookbook pattern, it's unclear what the right way to upgrade the Chef client is. There might be several ways of going about it. And one of these things that you'll need to figure out is how are you going to bootstrap all of these nodes? Particularly if you have a lot of nodes to bootstrap, like 2,000 nodes. We've had a lot of people reach out to us at Chef and say, hey, I'm bootstrapping 2,000 nodes, and I don't want to destroy your Fastly cache, so how do we do this? And you have to do some sort of special scripting or bootstrapping around it. That's not great. And a lot of times, knife isn't enough, right? You have to decide on what your upgrade strategy is. So I think a lot of people use the Chef Cookbook, which what that does is allow you to upgrade Chef in place. But it comes with a lot of trade-offs. And I call this the looking at your own eye problem. So imagine you didn't have a mirror and you tried to look at your own eye. It's very difficult to do, right? So the strategies for upgrading it using that method are not perfect. They work most of the time, but sometimes there are scenarios that you get into where you can't do that. And because the upgrade process is separated from your cookbooks themselves, you might end up with incompatibilities between Chef Client and your cookbooks across different environments. So yeah, you upgraded all the Chef clients over here, but oops, you forgot this one node, or this one node failed, but all the other 500 were successful. With Effortless Pattern, we treat it just like an app. So the Chef client and the cookbooks are bundled together, and the Chef client upgrades itself. It's able to do that because it uses Habitat. And yeah, it's built and moved together. So these problems start getting really obvious once you become a large organization and you're running 2,000 plus nodes on a single Chef Infra server. With the environment cookbook pattern, you're going to need complex pipelines to coordinate cookbook versions and environment pins. If your Chef server is down, you're dead in the water. And you can only deploy your Chef client and new versions of your Chef client at the interval in splay that you have set. So a lot of people have this just set to the default, which is 30 minutes. So you might be waiting 30 minutes for that initial deployment to happen. And I know a lot of people use the Chef Infra client to build their own little deployment system or to deploy system-level changes, that sort of thing. And you don't want to be there on a Friday night waiting 30 minutes for the thing to converge, only to watch it fail, and then move a change into Git, and then watch it, and then wait 30 more minutes. You want to run it right So Effortless doesn't use a Chef Infra server. It runs completely independently. It does require Habitat Builder or an artifact storage solution plus a deployment process. So that's one change, since you don't have the Chef Infra server, which is serving the role as an artifact server in the environment Cookbook pattern. Since you don't have Chef Infra server, Chef Search doesn't work, which may not actually be a problem. That might actually be a good thing. And we can talk, well, if we have time, we'll get to that. And it deploys at the pole of the speed of the Habitat supervisor, which by default is once per minute. So that first run of a new package runs very quickly. So the Chef Infra client runtime. So a lot of your best practices for the Chef Infra client need to be discovered, if you're using the environment Cookbook pattern, a lot of times they need to be discovered organically. You might discover this through a community summit or on the community Slack or Discourse or someone else at your company who's a chef expert. But it's really hard to get all of your cookbooks in what you believe is the good way of doing things, right? In some challenging environments, you may need to bundle certs, and you have to figure those out at runtime in the environment Cookbook pattern. This is an edge case, I think, for a lot of people, but when the dep solver runs, sometimes it can be a huge resource usage, particularly if you have a lot of cookbooks or you're running Ruby code in your metadata.rb and iterating over cookbooks or other things like that. It can cause a lot of problems if that isn't already solved. And so with the policy file over in the Effortless pattern, the dep solver is already run at build time. So we don't have to worry about that. You can bundle certs with the build. We can pin to old versions as we need. And the run hook and the scaffolding already has the best practices that we need automatically built in. So I'm not going to go too much into stateful data, other than to say that it can be a pain in the butt. And in the environment Cookbook pattern particularly, one thing I'll mention is that there's 15 levels of attribute precedence. So if you've ever used attributes to override things, you know that when they fail, not when you're overriding them. They work great when you're overriding them. But when they fail, figuring out what failed is really, really difficult. And it's not just because of 15 levels of attribute precedence. It's also the source of where the thing was overridden. And a lot of times you can't find where that is. Maybe it was somewhere in your pipeline. So in the Effortless pattern, by bundling everything together, by having the policy file be that one document that outlines everything, we don't have to worry about that. And the other thing that, not to alarm you too much, you're like, well, do I have to do a build every time I change an attribute? Geez. We do have a way in the Effortless pattern using what's called a user toml and habitat that at runtime, you can override those attributes as well if you need to do that. But by doing that, you're actually reducing the surface area of where things can go wrong just to 3 places, to the cookbooks, to the policy file, and to that user toml at runtime. And they're very easy to find if things are going to go wrong. So there's a couple things to avoid in this pattern if you decide to use this. The first thing is that you shouldn't use the Chef Infra client to manage Habitat up, right? The Habitat has built-in management capabilities. It manages the Chef client as an app. There are bootstrap scenarios where it does make sense to have a little cookbook that bootstraps the Habitat supervisor, and then you install your new package that has Chef Client bundled into it, and then you uninstall the Chef Client from the system, because now it's installed with Habitat. And that's probably the only scenario I could think that this would be great. But if you know of a good one, then please, I would love to hear about it. Don't run multiple packages on the same system. So if you have multiple packages running under the supervisor, then what's going on is that you have multiple Chef Client runs happening on a little OODA loop. And you want to be extra careful packaging large artifacts, multiple gigabytes in size. But wait a second, hold on. Doesn't Habitat need some special scripting and bootstrapping to upgrade it now? Didn't you just move the problem to Habitat? And the answer to that is, well, yes, but actually no. So Habitat is, we've learned a lot over the years from Chef, and Habitat is engineered a lot better at being able to upgrade itself. So it actually has two components. One is called the launcher, and the launcher is specifically designed to not change very much, or very rarely. And the whole point of the launcher is to be the supervisor for the supervisor. It launches the supervisor, and it upgrades the supervisor. So in that sense, Habitat is much more adroit, much more agile at updating itself. And very rarely, you may need to go and update the launcher. Very, very rarely. I think, I mean, I have more slides, but I want to pause here for at least a few minutes of questions from folks. There's some folks with the microphones who are going to come around.
Thank you. Hi, thank you. So I have a quick question about how would you suggest dealing with sensitive data, like encrypted data bags or Chef Vault?
I'm going to get to this here. Yeah, so in this scenario, you do lose Chef server. So if you're using encrypted data bags today, then that's something that you're going to lose access to, right? So I would love to talk to you more about the exact use case for why you're using encrypted data bags. The folks that I've talked to already, they've indicated that the way that either Chef Vault or encrypted data bags does not provide 2019 level kinds of capabilities, and that they're migrating to HashiCorp Vault, and I think that's a good move.
Following up on that question, we use the private keys for Chef's server issued to the clients to auth against HashiCorp's Vault. Is there a way to do that?
Oh, so basically you're using Chef server as like a private key generator.
Correct.
Yeah. If you wanted to use this pattern, you might need to rethink that.
Okay.
I think there might be a really good way to do that in this pattern, actually, where you could just generate the keys in Bash in the run hook. Yeah, let's talk about it offline. We can kind of noodle on it. That might be good for the hack day. That sounds pretty simple, actually.
Why was losing Chef search an okay thing or?
Oh, yes. Sorry, I didn't have time to get to it. So Habitat gives us a lot of capabilities that we didn't have in Chef Search. So what you'll see in cookbooks that are application-oriented, that are doing things like configuring Prometheus or Redis or a PostgreSQL cluster or Elasticsearch, things that need clustering, is that they'll use Chef Search to reach out to the Chef server as a source of truth, grab all the IPs and do some +1 Ruby math on top of them to sort of figure out which ones are the leaders and which ones are the followers. Habitat has a built-in gossip layer, and it can do automatic leader election to determine, okay, this is the leader and these are the followers. So if you switch your cookbooks out for Habitat packages in that scenario, not only do you get something that is the same as what you had before, but it's actually a lot stronger than what you had before and less failure prone.
How does the promotion paradigm with Habitat channels work with Policyfiles? And if you use policy groups right now for promotion, like with acceptance and production groups, are those the same thing? Should there be like policy groups within each channel for that subset of promotion?
So the first thing I'll say is that channels aren't necessarily environments. Channels are simply just a way to map a node to a thing that you want to promote to, and then that node will upgrade itself. So channels are completely arbitrary besides the two special channels, unstable and stable. So you're welcome to kind of craft those however you want. So if you need to map policy files to or policy groups to channels, you could do that. If you need to do like geolocate your production environments by data center or whatever and have different channels for those, you can do that. I'm not sure I answered your question.
Yeah, I guess if we're currently using policy groups for promotion, like you can migrate that workflow to channels.
Oh, yes,
yeah.
absolutely.
Okay,
yeah.
you don't need to like maintain both, I guess is what I'm asking.
And I think it would be stronger since the node subscribes directly to that channel. So you have a promise that the node is making to is making.
Cool, thanks.
This model is really cool. We're already looking at using like local Chef without the server. But I'm curious, will this work on desktops? Will this work on Mac OS?
That's a really great question. I think I know what you're getting at. This will work everywhere that Habitat works. So currently, Habitat compiles for 64-bit Linux and 64-bit Windows. It does not currently run on Mac. If you want it to run on Mac, then I have some people that you can talk to, and we can make that happen. So Habitat's written in Rust, so I don't think there's anything in Rust that would hold us back from doing that. It's just a matter of sitting down and doing it.
Is there a way to tweak this pattern to include the Chef infrastructure server?
Yeah, actually, that's a really good question. And I've been asked that a few times. So you totally could, right? So you could pick up the Chef scaffolding, and instead of running Chef client Z, you leave off the Z and then provide it a key that it could connect to the Chef server. The trick with that is that you would also have to change the structure of the build so that instead of exporting the policy file so that it runs in Chef 0, that you just ship the policy file up to Chef server. So yes, you can do it. You violate a few of the guarantees of packaging everything together because now you have the policy file and maybe some of your other artifacts living on Chef Infra server as well. But it's totally possible if you want to do it that way.
With the effortless config, would it be possible to configure firewalls?
Give me a little bit more detail. What do you mean?
So, for example, just set the state of the firewall, or just basically make a configuration for the firewall instead of a server. Because for firewalls, you can SSH to them in most cases for most providers.
Yeah, I think that would be a little bit lower level. It's not dependent on this pattern at all. That's dependent on the capabilities of what Chef or Habitat could do for your particular firewall. In a lot of cases, what I see firewalls as is more of sort of infrastructure level, not sort of application level. So that's something that personally I would put in my provisioning framework, like something like Terraform or Kubernetes or something like that that can reach out to that API. It really depends on which firewall it is and what your use case is.
So with your artifact promotion or your habitat promotion and the different channels for the subscription pattern, can you have different deployment methods depending on which channel you're subscribed to? For example, can your dev and test be automated deployment, whereas your production is your air gap environment? So you need a different deployment method off that channel.
Sure. The thing is that Habitat makes no opinion about that. So Habitat lives within your scheduler or your provisioner or your CI or whatever you're using for your deployment tool. So your deployment tool would automatically promote it to where you wanted it to do and do all the things that you wanted it to do around Habitat. So Habitat isn't like a CI/CD system. It just has that capability built into it. So it's really easy for your Jenkins pipeline or Circle CI or whatever you're using to automatically do that for you. And so, yeah, you could totally do that for those two environments. And then your air-gapped environment, you can totally put the heart files and promote those with your CI up to like an Artifactory somewhere or a S3 bucket or whatever, and then literally stick them on a USB drive and walk them over to your air-gapped environment.
So if you have multiple groups contributing hab packages to sort of manage the same system, and one of the things you warned against is having multiple Chef client instances running, it doesn't make sense to me to pile everybody's code into one hab package because it breaks up the modularization that you're kind of going for. So how do you manage that dependency between, infrastructure team packages something that has Chef client on it, and then the application team puts something on it that depends on Chef client? And
yeah, exactly. I understand what you're saying. So the first step is, I think your source control is going to be the first place where you look to for that collaboration point. And so the policy file you should look at very carefully and understand where all those sources are coming from. So if you need to make the workflow, hey, these people upload their cookbook here, and that's where the dev artifact lives, the cookbook lives, and then the policy file is sort of the amalgamation of all those things, then that's one way to do it. The other way to do it is to kind of start out with that, and as you're migrating to this pattern, is to start out with a policy file as sort of that amalgamation, and then have the application teams build habitat packages instead. And that way, everything is singular and modular, and you can deploy completely independent of each other without having to worry about the Chef client at all. And then those applications just simply run with their binaries and with their run hooks in Habitat. I think we're at time, or beyond time, so thank you very much, everyone. I was very honored to speak for you.